Hey guys, so I know a lot of you online have been having some trouble with the worksheet I put up. I was going to go through the first page of this worksheet with you in this video to help explain and hopefully clear up some misconceptions you guys have about it. So, all these worksheets that you got have a balanced chemical equation at the top. First question is just finding molar ratios. So let's go through again, just like we did in the last video, how to find molar ratios. You are setting one reactant equal to one product, and you're adding the unit mole in there. So I'm going to start with this reactant and go through for each of my products. 1 mole AlBr3, set it equal to one of our products, 3 moles KBr. Okay, so that's 1 molar ratio. I can use the same reactant here and set it equal to my other product, 1 mole Al. Alright, so I've done both of my molar ratios for this reactant. If I use my other reactant, again I have to add moles in there, 3 moles of K equals, I'm going to start again with this product, 3 moles KBr. Same reactant again, but different product now. 3 moles of K equals 1 mole of Al. Alright, so there are 4 molar ratios from just this one equation. Okay, of course, we could do some different ones for different purposes, but right now that is perfect for us. Alright, on to number 2. Alright, I have some of my stuff set up already here. Let's look at the question first though. If 15 moles of potassium are used in this reaction, how many moles of aluminum will be produced? So again, let's always start by finding what we're going to answer this question in. It wants to know how many moles of aluminum. So my goal at the end of this conversion problem, I should have moles as my unit, and my formula should be aluminum. What am I starting with here? What do I have to begin with? 15 moles of potassium. That's what's going to be used in this reaction, and wants to know how many moles of aluminum will be produced from this amount of potassium. So I fill that in for my start. 15 moles of potassium. Okay. Just like the last video, I want to see if I need a molar ratio. So I look at my start and my finish. I notice I have different formulas here, so I will need a molar ratio. Okay. I have potassium and aluminum. So if I look back at what I just found, potassium and aluminum here, this molar ratio will help me out, so I can use that. I will write that down on the side here. 3 moles of potassium equals 1 mole aluminum. Nice. All right, now let's check the units here. I have moles and moles, so I don't need any other conversion factors here. This will handle everything I need in this problem. So it's just a one-step conversion here. I'm going to look at my conversion factor and line it up so that moles of potassium will cancel out. So this is the side that has moles of potassium. I need to put that on the bottom. 3 moles of K. The other side goes up top. 1 mole of aluminum. Moles K cancels out. I have my end unit, moles aluminum. Now I can do my math. So 15 times 1 up top is 15. Everything in the bottom is just a 3. 15 divided by 3 is 5, and that goes with my unit, 5 moles of aluminum. Right? That is number 2. Okay, one-step problem. If we look at number 3, okay, this one's going to be a 2-step problem. Okay, so again, same way as number 2. We want to find our end and then find our start. So how many moles of KBr will be produced if 205 grams of AlBr3 are used in the reaction? It wants to know how many moles of KBr. So I'm going to put that in my goal unit. Moles is the unit, KBr is the formula. Now, what do I have to begin with? 205 grams of AlBr3. I will put that in my start. 205 grams AlBr3. Nice, I have my start and I have my finish. Let's check if we need a molar ratio. We compare the two formulas, AlBr3 and KBr. They are not the same formula. So I will need a molar ratio. I'm looking for one that has AlBr3 and KBr. If I go back to the ones I made in the beginning, AlBr3, KBr, so I will use this molar ratio in this problem. Okay, so I'll write that down on the side for us here. 1 mole AlBr3 equals 3 moles KBr. Nice. All right, next I'm going to look at my units. I'm going to start in grams over here. So I won't be able to use this molar ratio until I switch this to moles of AlBr3. So I will need a molar mass to go from grams of AlBr3 to moles of AlBr3. Right? I have that written out already for us. So 80.946 grams of AlBr3 will equal 1 mole AlBr3. Okay. After I use my molar ratio, I will be in moles of KBr, and that is what our goal unit is, so I will not need any other conversion factors for this one. Now I just need to line my conversion factors up in my chart and do the math. So looking at grams of AlBr3 as my start, I need this conversion factor that has that unit in it. Not worrying about the math right now, just worried about those units lining up so they will cancel out. So I'm just looking at, I have grams AlBr3 and grams AlBr3. I use that side, I need the other side. 1 mole AlBr3 up top. Separate these, I use this conversion factor already. Grams AlBr3 cancels out. Now I'm in moles AlBr3, almost at moles of KBr. This is where my molar ratio comes in. It will allow me to switch that formula. So 1 mole of AlBr3 at the bottom. And the other side has to go up top. 3 moles KBr up top. And that side is done. All right, moles AlBr3 cancels out. I have moles KBr. That is my goal unit. Now I just need to do the math. So everything up top gets multiplied. 205 times 3, it's going to give us 615. And in the bottom, 80.946, it's just going to be times 1, so I just need to divide by that number, 80.946. And that is going to give me 7.598. Right? That goes along with our end unit. So 205 grams of aluminum bromide will give us 7.598 moles of potassium bromide. Cool. Next one. Okay. So it's going to be a little bit longer. It's going to be a 3-step conversion problem. I'm going to start, or wait, let's find our end first. So it wants us to end in grams of aluminum. I'm going to put that as my goal unit, grams Al. And we will begin with 785 grams of potassium. So 785 grams of K. Cool. All right, if I look, I have 2 different formulas in my start and my finish, so I will need a molar ratio. If I go back up top, I'm looking for K and Al compared together. I have K and Al. It's one I used already. It's okay. We can use it again. All right, so I will have 3 moles of potassium equals 1 mole of aluminum. And in this problem, we're going to start in grams and we're going to finish in grams. So we're going to need 2 molar masses, 1 for potassium and 1 for aluminum. So we're going to use the periodic table to find those numbers. 26.982 grams of aluminum is equal to 1 mole of aluminum, and 39.098 grams of potassium is 1 mole of potassium. Cool. I'm going to start in grams, use this molar mass to switch to moles of aluminum, use my molar ratio to switch from moles of aluminum to moles of potassium, and then from moles of potassium back to grams of potassium. I'm sorry, from moles of aluminum back to grams of aluminum. So I will end up with grams of aluminum here. I just need to line all my conversion factors up in here so that everything cancels out and I do the math the right way. So I'm starting with grams of potassium. I need grams of potassium in the bottom here to cancel out. So I need this molar mass first. 39.098 grams of K in the bottom, and up top, 1 mole of K. Grams of K, it cancels out. I'm in moles of potassium, I'm getting closer to my end unit. Now I want to switch my formula. I'm in moles, so I can use my molar ratio. All right, first I want moles of potassium to be on the bottom. That's this right here. 3 moles of K in the bottom, and the other side goes up top. 1 mole of aluminum. Done with my molar ratio. I have the right formula now. I just need to switch moles back to grams. So I'm going to use my final molar mass. I have moles of aluminum in the top, so moles of aluminum is going to go on the bottom to cancel out. And my other side goes up top, 26.982 grams of aluminum. Moles of potassium canceled out over here, moles of aluminum canceled out here. I only have grams of aluminum left, and that is my end goal. So now I just need to do the math. 785 times, I leave the ones out to make it easier, 26.982. Up top, that will give me a pretty large number. Don't freak out about that, it's okay. 21,180.87. Don't forget your bottom, 39.098 times 3. And that will give me 117.294 in the bottom. Gonna divide the top by the bottom now, and I will get 180.579. This goes with my end unit. 180.579 grams of aluminum. That is my final answer. Okay guys, hopefully that is helpful for these worksheets. Problems work just the same way on the other sheets, but it's just going to be a different balanced equation up top. All right, so you'll have different molar ratios, and of course it's going to have some different numbers in there. But essentially they all work exactly the same way. Take your time, write out your charts, write all your units, and you guys will be okay.